Let's start with Unit 1, Discrete Structures and Optimization. What is the probability that a positive integer selected at random from the set of positive integer not exceeding 100 is divisible by either 2 or 5? When you consider integers, you have negative numbers, you have 0, and then you have positive numbers. When we say it's a set of positive numbers, it means it starts from 1, and they say not exceeding 100. It means the limit will be 100. You should not go above 100. They are asking it should either be divisible by 2 or by 5. So let's see the numbers that are divisible by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, 92, 94, 96, 98, 100. In this, we can also understand that 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, they are also divisible by 5. So 2 and 5 combo is also available in this list. Now let's see what are the numbers divisible by 5. This list has 5, 15, 25, 35, 45, 55, 65, 75, 85 and 95. In fact, 10, 20 should also accompany in the list of divisibility by 5. But since I have included in divisibility by 2, I have not included in 5. So altogether there are 60 numbers. So there are 50 numbers in divisibility by 2 and 10 numbers in divisibility by 5. So altogether we have 60 numbers that are either divisible by 2 or divisible by 5. So what are the total count of numbers for which we have to take the probability is 100. So the probability will be 60 divided by 100. So when we cancel the zeros, then 2 3s are 6 and 2 5s are 10. So we have a probability of 3 by 5 for a positive integer to be selected at random from the set of positive integers not exceeding 100, which will be divisible either by 2 or 5. Option number 2, 3 by 5 will be the right answer. This is the direct way of solving. If you get into the formula method, we have a formula called probability of A union B, which is equal to probability of A plus probability of B minus probability of A intersection B. This probability of A will include numbers which are just divisible by 2. This probability of B will include numbers that are divisible only by 5, and probability of A intersection B will be that are divisible by both 2 and 5. And this probability of A union B will give you the probability that the number is divisible by either 2 or 5. Probability of A will be 50 actually. So we have to take it as 50 by 100. So 50 numbers are divisible by 2 alone. This list that I have given here does not include 10, 20, 30 because since it was already available in divisible by 2, I did not include this. But to take the probability that has the numbers that are divisible only by 5, I have to include this list. So this will give me altogether 20 numbers. So 10 from this column and 10 from this column. Now the intersection part is actually this set of 10 numbers. They are actually divisible by 2 as well as by 5. So I have to write here as 10 divided by 100. So altogether 50 plus 20 will give me 70. 70 minus 10 will give 60 divided by 100. Even if you go by formula method, you get the same answer, 3 divided by 5. Next question, if universe of disclosure, actually it is universe of discourse, are all real numbers, then which of the following are true? Not only in this question, even in the upcoming questions you can find the word disclosure. Many mathematical statements assert means they declare that a property is true for all values of a variable in a particular domain, called the domain of discourse or the universe of discourse. It means when they say it's a universe of discourse of all real numbers, it means a particular proposition or a particular expression that is given in the option is true for all the real numbers. We have natural numbers, we have whole numbers, and if we take integers, we also have negative numbers included. Then for real numbers, we also include the fractional parts like 1 by 2 or 3 by 5, something like that. So real number will include even decimal related numbers. It means floating point numbers, as in programming context we used to say. So which of the following are true? Actually, this question is available in Kenneth Rosen's Discrete Mathematics 7th edition book as a exercise question. And regarding this question, what was the actual question that was asked in the book was, translate these expressions into English statements. This was the actual question that was available in the book, but here they are asking which of the following are true. So in order to understand what these expressions mean, first we will translate them into normal English words. Then we will find out whichever is true. First statement. So when we say there exists, it means there is a number or there exists a number or for a particular value or number. So this symbol means there exists, and this symbol means for all, for every. Inclusion of everything is this symbol, and telling that something is existing is this symbol. So now we will translate this. There is a real number x such that for every real number y, the sum of x and y will be equal to y. So here we can consider x is a real number. So let's take x is equal to 0. So 0 is also a real number. And let's take y is equal to any number. I mean, it should be applicable for all real numbers. You have to include all real numbers. You take y is equal to 1 for example. Anything that you add with 0 will give you the same number y. So when I say 1, it is 1. When I say it is minus 1, then you have 0 minus 1 is equal to minus 1. When I say it is 3 by 2, 0 plus 3 by 2 will give you 3 by 2 again. So whatever number you add with 0, you will get the same number. Now just apply this to the expression. There is a real number x. It means x can have at least one value. X has a value of 0 in this particular statement. So this there exists a real number is true. When I am applying this x value 0 to any number that is available in the real number set, it will give the value of the same number. So this statement is true. Whenever I add any number to 0, I will get the same number. So I can say that this statement is true. So A is true. Now we will translate the next statement. This statement states that for every real number x, it means for every x value, and for every real number y, they have given a condition. When they have given some condition, you have to take this as, if these two conditions are true, then this implies operator will tell you then this condition is also true. So now we will translate. If x is greater than or equal to 0 and y is less than 0. So let's take x is equal to 1 and y is less than 0. We will take it as y is equal to minus 1. That is, this statement says that for real numbers x and y, if x is positive and y is negative. So x is positive and y is negative. When they say x is greater than or equal to 0, this states that particular number is going to be positive. When they say y is less than 0, it means it is a negative number. Then they say x minus y is positive, which they have marked as greater than 0. So we will just subtract this. 1 minus of minus 1, this is x minus y, which is equal to 1 plus 1, it will give 2. This states that it is greater than 0. So whenever I use subtraction with a negative number, any negative numbers, even if you have minus 10, when you have minus of minus 10, it automatically converts into plus 10 or plus any number. So when you have positive number this side, and when you use subtraction with a negative number, this will be positive number plus this particular positive number. So positive and positive will always yield a positive value, which states that statement B is also true. Now we'll get into the C statement. There is a real number X and there is a real number Y. It means you can have even a single value. X is less than or equal to 0 and Y is less than or equal to 0 such that X minus Y is greater than 0. They say that X minus Y is positive when X is negative and Y is negative. Let me take a number minus 5 for X, and for Y let me take something like minus 10. Now when I subtract X minus Y, this will give me minus 5 minus of minus 10, which is equal to minus 5 plus 10, and this will give me 5, which is ultimately greater than 0. So this statement is true only. Now they are saying there is a real number X and real number Y. It means it is not applicable for all X. Not for all X and not for all Y. It is for any number. So here I can say X has a value of minus 5 and Y has a value of minus 10. At least one value is there. Now let's apply this for 0 and see. X is equal to 0 and Y is equal to 0. And they say X minus Y is greater than 0. This fails for this particular value. But here the statement is there exists. When they say there is some value, it means there can be at least one value available. And we have a combo like minus 5 and minus 10 to make this statement true. This is more than enough. In case if the statement is for all X and for all Y, we can mark this particular expression to be false. But when it is there is a number and there is a number, this turns out to be true for at least one pair of values. So C is also true. Now let's translate the D expression for all X and for all Y. So here for every real number X and for every real number Y, if X is not equal to 0 and Y is not equal to 0, it can be of any number but not 0. If and only if. So by implies operator will be translated as if and only if their product is not equal to 0. So when I say X is not equal to 0, it means just take X is equal to 1. And when they say Y is not equal to 0, it is also equal to 1. If and only if X into Y not equal to 0. This will give X into Y as 1. When will we get a product to be 0? If a product is equal to 0, it means one of the operands should be 0. Either X or Y should be 0. Only then you will get a product of 0. When they say the product is not equal to 0, it means neither of the values are 0. It means X is also not 0 and Y is also not 0, which makes this statement also to be true. So D is also true. In this case, we are marking option number 4, A, B, C and D only as the right answer. So the book content will be like they will start with converting English statements to mathematical expression and then mathematical expression back to English statement, so that you will learn to write any statement in the form of quantifiers. So we will call these symbols as quantifiers. You are saying how much of the values are true or how much of the values are applicable for this. This will come under predicate logic and under the topic quantifiers. So in quantifiers, they will say how to convert normal English statement to quantifiers and expressions carrying quantifiers to normal English statements. So since that was the exercise, they have just altered the question as just mark which of the following are true. Now we'll move on to the next question. If the universe of discourse is a set of integers, now integers means you have to include negative numbers, 0 and positive numbers, then which of the following are true? This was the exact question that was found in the same exercise part of Kenneth Rosen's Discrete Mathematics book. Now we'll start with A. This statement is saying for every value of n, there is an integer m that is bigger than n square. Let's take 10 square, which is equal to 100. Now m is also an integer. What if m is going to be 999? Here m is only greater. It means for every n value, we can have a different m value. So this statement can be taken as no matter how large n might be, we can always find an integer m bigger than n square. This is certainly true. For example, we could always take m is equal to n square plus 1. When we have n square is equal to m, it means both the values are equal. When they say n square is greater, it means at least it is having plus 1 value extra than m. Here you cannot go with points because they are talking about integers. We can just increment it by 1 or decrement it by 1. In case n square is less than m, it means m is having at least one value greater than n square. So in this case I can translate this as m is equal to n square plus 1. So now just apply this. N square is less than n square plus 1. So instead of m, I am just substituting this expression here. So this is true, right? So that's why they have given this expression. So A is true. The only option that has included option A will be option number 1. Option 1 will be the right answer. A, B, C are true. Now we will just check. So this statement says there is a number n that is smaller than the square of every integer. Note that n is not allowed to depend on m since the exponential quantifier comes first. So which quantifier comes first matters a lot. This statement is true. Since we could take for example n is equal to minus 3, then we will have m is equal to 1. N is less than m square. Minus 3 is less than 1 will be true. Since squares are always greater than or equal to 0, m square is greater than n. This is just a reverse of A statement. Here instead of all n and n square, where they say it is less than for a particular m, here they are reversing like for a particular n, every square will be greater. So this makes sense and of course this turns out to be true. Now if I want to say n is equal to 0 and m is equal to 1, even now we can say 0 is less than 1. 1 square which is equal to 1. So this statement is also true. B is also included. Now there exists a value n. For all m, n into m is equal to m. Which number has to be multiplied by every number so that we get the same number? Here n is equal to 1. For any number m, you will get m into 1 is equal to m. If it is 10, you will get 10. If it is minus 3, you will get minus 3. If it is 0, you will get 0. In the previous question we saw, if x is equal to 0, anything that is added to this 0 will give you the same number. The same case is here. Anything that you multiply with 1, you will get the same number. So C is also true. So here the there exists is applicable for n, for which I can say n is equal to 1. Now we will get into D. They have given a particular equation. There exists a number n and there exists a number m. It means they can take a particular value also. N square plus m square is equal to 6. So if I take 1 and 1, it will give me 2. Then if we take 1 square and 2 square as 4, it will give 5. Then if we take 2 square 4 plus 2 square 4, it will give 8. There is no possibility that we will get 6. Which numbers, when they are squared and added together, they will give 6. There is no such number available for a particular value of n or particular value of m. There is no way that you can get 6. That's why D is out of the choice. So D is actually false. Next we will check E. There exists a number n and there exists a number m. So n and m can take a particular value where n plus m is equal to 4 and n minus m is equal to 1. Now we have to randomly check if some number is going to give you 4 and their difference is going to give you 1. For which number it will get satisfied is they have given some values. So this was available in the solution book. I just used the same thing. When n is equal to 2.5 and m is equal to 1.5, we can get the value of the sum to be 4 and the value of the difference to be 1. This is right. But what is n and m? They have given the universe of discourse as set of integers, which means no fractions have to be included. Only negative numbers, 0 and positive numbers should be included. In that case, 2.5 is not an integer, 1.5 is not an integer. If this is a discourse of set of real numbers, this statement could have been marked true because I at least have one n value and I have one m value. If this was a part of real number, this is going to be true. But since the question is this is a part of integer, we will mark this as false. So statement E is also false. If n is equal to 2.5 and m is equal to 1.5, this will satisfy n plus m is equal to 4 and n minus 1 is equal to 1. By algebra, we see that this is a unique solution to the particular equation. Since they do not exist integers that makes the equations true, the statement is false. So D and E are alone false here. So we are marking option number 1, A, B and C to be true. Here I would like to tell you one more information. As per the official answer key, option 2 was declared as the right answer. So only B and C were declared as the right answer in the official answer key, but the actual answer will be A, B and C. This is actually taken from the respective discrete mathematics book solution. Next question, if n square is equal to n into n, where n is the set of natural numbers in the sense 1, 2, 3 and it goes on. So natural numbers will be 1, 2, 3, whole numbers will be from 0 and integers will be negative numbers, 0 and positive numbers. -2, -1, 0, 1, 2 and it goes on this side too. And R is a relation on n square. Show that R belongs to n square into n square. That is, variable x, it's a natural number. Variable y, it's a natural number. Again, variable u, it's a natural number. And variable v is a natural number. Now just represent this as a relation. X comma y relation u comma v states that x into v equal to y into u. X is also a natural number, v is also a natural number, which is actually n square here, n into n. And similarly, y is a natural number and u is a natural number, so this is also n square. Now they are asking which of the following are true. They are asking us to check for reflexive, symmetric, transitive and asymmetric. Let's see what is reflexive. A relation is said to be reflexive if for every element A that belongs to a set A, we have A comma A that belongs to the particular relation. Let's check for reflexive. Now this is X, this is Y, this is U and this is V. So XV is equal to YU. So in place of X I have X, in place of V I have Y, which is equal to, in place of Y I have Y, in place of U I have X. This is also equal to X into Y. So XY is equal to XY, which states that reflexive property is true. So A is true. Now I can rule out second option because A is not present. Now we have to check for symmetric property. So when we have to check for symmetric property, we will also see about asymmetric and antisymmetric. So a relation is symmetric if for all x comma y that belongs to R states that y comma x also belongs to R. So this is the condition of symmetry. When it is asymmetric, it means that y comma x will not belong to R. So the exact opposite of symmetric will be asymmetric. So if I take 1 comma 2, then 2 comma 1 must also be a part of R. But in asymmetric, if I say 1 comma 2 belongs to R, then 2 comma 1 will not belong to R. This is asymmetric. Then what is antisymmetric? Here the case is x and y are not equal. In case they say x comma y and y comma x both belong to R, it means the antisymmetric property states that x must be equal to y. So what happens if x is not equal to y? then the asymmetric property will be true. So if x is equal to y, symmetric property will be true. If x is not equal to y, the asymmetric property will be true. But how have they rephrased it is, if x comma y belongs to R and x is not equal to y, we can state that y comma x does not belong to R. So they have rephrased in this way. I thought that these statements would give you a clarity on symmetric, asymmetric and antisymmetric. That's why I've included them. Now we'll check for symmetric. So let's take x comma y relation u comma v, which is equal to xv is equal to yu. Now we can write this as yu equal to xv, and I can interchange this as, make this as ordered pair. So instead of x I have u, instead of y I have v, relation instead of v I have y, instead of u I have x. So this particular x comma y as of now is equal to y comma x, which says that symmetric property is also true. So we can mark B to be true. So A, B are included. We have to check for C to find whether it is option number 1 or option number 4. So option 3 can also be ruled out. So let's check for transitivity. Say for example, if x comma y relation u comma v and u comma v relation a comma b, which implies that x comma y relation a comma b. So this is like if a comma b and b comma c, then it is a comma c. Now we have to prove this. So let's go with the first part, x comma y relation u comma v, which states that xv is equal to yu. Then we have u comma v relation a comma b, which states ub equal to va. Now we'll just equate both the things. So left hand together in one side, xv, then we have ub, then right hand side together yu and va. X UVB or VUB, which is equal to YUVA. So UV and UV can get cancelled here. So ultimately we will have XB and YA. Now change this as relation. You will have X comma Y relation A comma B. When you equated these two as right hand side and left hand side, you get this. So transitivity property is also true. So from this we can say asymmetric property is not there. We can rule out even option 1 here. So we'll go with option 4. A, B and C only will be the right answer. Asymmetric is stating that there is no y comma x, but here since it's a product, we are just making it as y into u as u into y, and since this is also a product, we are making it as v into x. So we have an option to change this because it's just a product. Since this symmetric property is possible, we can never say that y comma x does not belong to R when it comes to multiplication, because 1 into 2 will give 2, 2 into 1 will also give 2, 3 into 2 will give you 6, 2 into 3 will also give you 6. So in case of this particular x into v and y into u, which comes with multiplication, asymmetric property cannot be true. That's why we are ruling out D, asymmetric option from the list. So let's see the transitive property. If A comma B belongs to R and B comma C belongs to R, then A comma C also belongs to R. So this is what I have mentioned as A, B, B, C and AC. Next question, which of the following are tautology? Tautology means when you take a truth table, the final column, the result column should have 1 everywhere. So to check for tautology, we have only one option. You have to draw truth table. On the whole, you can even simplify the expression. But at last, when you apply this in truth table, it should end up with 1 in the final result column. Tautology is always true for every value of its propositional variables. Now we will just see the truth table of certain operations. If we take P and Q alone, you have 4 set of values. So 0, 0, 0, 1, 1, 0 and 1, 1. When you take P and Q, whenever both P and Q are 1, you will have 1. Then we have P or Q. Whenever P and Q are 0, we will have 0. The rest of the case it is 1. Then we have P implies Q. It means if P then Q. P implies Q will have a truth table like when P is equal to 1 and Q is equal to 0, only in that case we will have 0. Rest of the case it is 1. At least you should know this basic set of truth table, only then you will be able to work for this question. So let's get into the A option. P implies P and Q. The result implies P implies Q. First we will find this P implies Q. So we have 1, 1, 0, 1 from this particular column. Then we have P and Q we will solve. So P and Q will be 0, 0, 0, 1. So 0 into 0 is 0, 0 into 1 is 0 again, 1 into 0 is also 0, 1 into 1 is 1. Now we will find for P implies P and Q. So what is P here? 0, 0, 1, 1. What is P and Q? 0, 0, 0, 1. Now what is P implies P and Q? So 0, 0 I will have 1, 0, 0 I will have 1. When it has a combo of 1 and 0, as in this case I have to mark this to be 0, and 1 and 1 will also give me 1 only. So only in this case I have 0, consider only this. Now result of P implies P and Q. This will have the values 1, 1, 0, 1. What is P implies Q? 1, 1, 0, 1. So here we will have it as 1, 1, 0, 1. Now we have to find implies operation here. Just check the first value should have 1 and the second value should have 0. Only then you will have 0. So you have 1 and 1. Here it is 1. Then you have 1 and 1. Here it is 1. Then you have 0 and 0. It is 1. 1 and 1. It has 1. So did you get 1 in the final result here? This is the final result column. So is everything 1? It means A is a tautology. So whichever options did not include A will be ruled out. Now we have to check if B is tautology or not. That will be more than enough for this question. So let's check B. So the B expression will be P implies Q implies Q implies P or Q. So first we will go with P or Q. P or Q will give you 0 or 0 is 0, rest will be 1. Then P implies Q will have 1, 1, 0, 1. So let's go with P implies Q. We'll just place the values here. Then we have Q here. So only the Q column. 0, 1, 0, 1. Implies operator between 1 and 0 will alone give you 0 as per this table. So this alone will be 0. The rest of the places it will have 1. So this is the final value of this column. So let me place this instead of this particular expression 0, 1, 1. Then we have P or Q. So place 0, 1, 1, 1. The value from this column. Now we have to use implies operator again. So which value will have 0, 1 and 0. So such case is not existing. So we will have 1 everywhere. Which means the final column, the result column is having 1 everywhere. Which means that B is also a tautology. So B is also right. From this we can say 1 and 2 are ruled out. Option number 3, A and B only will be the right answer. So for this question they have made it very simple that C and D are not tautology. So this is going to be false only. But in case if you want to check C or D, how should your truth table look like is, you have to use 8 set of values. So basically when it is only one variable P, it is just 0 and 1. When it is P and Q, it becomes 0, 0, 0, 1, 1, 0, 1, 1. 2 power 2 which is equal to 4. So this is 2 power 1 which is equal to 2. This is 2 power 2 equal to 4. When it is 3 variable P, Q, R, this is 2 power 3 which is equal to 8. When it is 4 variable P, Q, R, S, 2 power 4 is equal to 16 set of values. So here you will have 4 zeros, then you will have 0, 0, 0, 1, 1, 0, 1, 1. Then for 4 set of 1 values, you will have 0, 0, 0, 1, 1, 0 and 1, 1. So if you have to check, then you have to find not P, then P or not P, then implies with Q, then P or not P, that implies with R value. So you will need R value definitely. Similarly, this is also having R. So for practicing purpose, please do make truth tables for C and D in your notebook and learn to calculate this in a fast way. It's just my suggestion and also a kind of consideration to tell you that please practice 3 variable and 4 variable truth tables as much as you can, so that at times when you need, you can make use of truth table to easily solve some problem instead of going for simplification. So sometimes they will give you an expression in the question and ask you which expression is equivalent in the option. Sometimes we will not be able to simplify the expression due to stress or anxiety in the examination. At that time, you can use truth table method to easily find out which final columns are equal and say which is the answer. Next question. The statement P of x is equal to x square. If the universe of discourse consists of integers, which of the following will have truth values? So let's take P of 0. So here instead of x they have given 0, which means P of 0 states that 0 is equal to 0 square. So 0 is equal to 0. This is true. A has truth value. Then we will go for x is equal to 1, P of 1, which is equal to 1 is equal to 1 square. So this is x and this is x square, which says that 1 is equal to 1 and it is again true. This is also fine. Now we will check for P of 2. X is equal to 2. P of 2 states that 2 is equal to 2 square. No. 2 is not equal to 4, which means P of 2 is false. So this is false. Now there exists an integer x for which P of x is true. There is a x for which P of x is true. This is the English statement for this. Of course, we have x is equal to 0, then x is equal to 1, for which P of x is equal to true. This says that P of 0 is true and P of 1 is true. Is D right? Yes, it is perfectly right. Existential quantifier states that x should have at least one value. Here x has two values. So in integer we will have negative numbers, 0 and positive numbers. So there exists a x means there is one value at least. So here there are two values which states that it's true. Now we will check E. For every x, P of x is true. This is the statement and it is absolutely false, because for every x means you have to include negative numbers, 0 and positive numbers. But when we checked P of 2, that itself is false. When P of 2 is false, we can say it is not applicable for all integer x. So this states that E is false. A, B and D. The option that includes these three will be option number 3 will be the right answer. When x is equal to 0 and x is equal to 1, P of 0, P of 1 is true. When x is equal to 2, P of 2 is false. This is what we calculated from A, B and C. So when they say there exists a x, this condition can be applied. But when they say for all x, you don't have truth value for everything, which makes this to be false. Just go with some negative number. Minus 1 is equal to minus 1 the whole square, which means that minus 1 not equal to plus 1. So not all x is going to give you the truth value. So in that case, we are marking E to be false. Next question. Which of the following statements are truth statements if universe of discourse is a set of integers? So this time you have 4 problems on universe of discourse. So 3 problems belong to integers and 1 belong to real number. All these 4 problems are from Kenneth Rosen's Discrete Mathematics book, exercises part A. For all n square is greater than or equal to 0. So n is equal to minus 1. Minus 1 the whole square is equal to 1. It is greater than or equal to 0. It works for negative number. For 0, 0 square is greater than or equal to 0. It works for 0. For positive number, let's take n is equal to 1. 1 square is equal to 1, which is greater than or equal to 0. So it works for positive. So all n when they are squared will be greater than or equal to 0 is true. So A is true. This is for all n. And for B, there is a n where n square is equal to 2. Only when n is equal to root 2, if we square root 2, we will get 2. The square root and square get cancelled and we will get 2. Square root is not an integer and they are asking from the universe of discourse, which is a set of integers. Since square root of 2 is not an integer, B is marked as false. We have to find at least one value of n which will make this equation true. N square is equal to 2. But n has only one value for which if you square you will get 2. That value will be square root of 2. Square root of 2 is not an integer. So we are marking it to be false. Next, for all n square is greater than or equal to n. This is actually absolutely true. So if you take n is equal to minus 1. Minus 1 the whole square is greater than or equal to minus 1. 1 is greater than or equal to minus 1 is true. Then check for 0. 0 square is greater than or equal to 0. It is true. Then for 1. 1 square is greater than or equal to 1. 1 equal to 1, we are marking it to be true. Then we will go for 2. 2 square is greater than or equal to 2, which states that 4 is greater than or equal to 2. It is true. So for negative, positive and 0 integers, this statement is true. So C is true. Now we will check for D. There exists a value n. N square is less than 0. Let's take minus 5 or something. When you square a number, it means you are multiplying the number twice. So minus 5 square is equal to minus 5 into minus 5, which will automatically make this plus 25. And when you take a positive number as 5 square, so 5 into 5 will give you 25, which is again positive. They are saying at least one n, but there is no n for which the square of n will be negative. This statement means n square is negative. It's not at all possible. Plus into plus is equal to plus. Product will also be plus. And minus into minus will also give you plus. So at which case you will have negative product is when you multiply a positive and negative integer, you will get negative product. When you multiply a negative and positive integer, you will get negative product. But here you are multiplying n with n, which says that if n is negative, then this n is also negative. If n is positive, this n is also positive, which states that anyhow the product is going to be positive only. This will not be the case for n into n. So from this we can say that n square can never be negative, and so D is wrong. So option number 4, A and C will be the right answer. Rest of the options are wrong. Next question. Which of the following graphs are trees? A connected graph with no cycles is called a tree. If an unexplored edge leads to a vertex visited before, then the graph contains a cycle. So let's start with option A. So we will start with vertex A. From A we have to go to C. From C we have 3 branches, B, D and F. D and F. So from F we have E. Is this a tree? Yes, this is a tree. So A is included and A is included in all the options too. Now we will check for B. So we will start with A. A has 2 branches, C and F. So it is a intersecting edge, but you have to go to F. So we will have C and we will have F here. From F we have D and from F we have E. E and D. From E we have B. And B has no connection with A or D or something, so the tree can be drawn this way. So this is also a tree. B is also included. So whichever options have excluded B, we can rule out 3. Now we will go to C. Let's start with A. We have 3 branches, C, D and B. You can ask me why I am naming in this order. Whichever is coming left side, I am just marking it as left. Whichever is going right side, I am marking it as right. I am not following any other convention. I am just using the graph and just making it to be a tree. From C we have F. From D we have E. From E we have B. And from A we have B. So if you take this particular part, this makes a cycle. So they say a connected graph with no cycles. So in this case there is a cycle. So C is not a tree. C option has to be excluded. So this fourth option is also wrong. Now we'll check for D. A has an edge to F. This is over. Now we have to check for B and D. B has for D and it has for E and he has for C. So if we take like this C, E, B, D. So this is one tree and this is one tree and both are disconnected. Though they are given in the form of intersecting edges, they are disconnected. A connected graph with no cycles, which says that this is disconnected. Since it is disconnected, we are excluding option D also. Options A and B are alone trees. So option number 1 will be the right answer. We will rule out even 2. I hope you understood how we excluded C and D. Just see the second point. If an unexplored edge leads to a vertex visited before. So when I get into D and E, the next edge is getting back to B again, which is already a visited vertex as per this context. So it makes a cycle here and that's why we are excluding C. Next question, match list 1 with list 2. Before getting into the solution, we'll just learn about 2 symbols. The first symbol is this and the second symbol will be this one. So what is it? On seeing this symbol, we can understand that it is an empty set. That is, the set contains no element. How do you represent an empty set? Is using the phi symbol. So this phi symbol is equal to this symbol. So whenever we say it's an empty set, it means the set does not contain any element inside it. Then what is this symbol? This is actually a set. Inside the set we have one element. It means it is not an empty set on the whole. But inside the set you have this symbol here. What does this mean? So inside there is a set that is an empty set. So we can say this is a set with one element and that element is an empty set. So the set with empty set will be represented this way. This is a set. So we can keep the set symbol as it is. Now instead of the empty set symbol, we will use this phi. So instead of this, we will use phi. So whenever they say it's a phi symbol, it means it's an empty set. And whenever they say a phi symbol inside a set, it means an empty set that is present inside the set. It means the set is with one element and that element is empty set. Empty set inside a set is a set of sets. It's a set containing a single element, as I said, and that element is the empty set. So what is an empty set? The empty set is a set that contains 0 elements. It means no elements are present. The set of an empty set is not an empty set. This is what they have mentioned in this symbol. It has an element even if that element is itself a set with no elements. We are not bothered about what is inside the set. We are only bothered that the set contains something. We have 2 operations here. One is the union operation and the other one is intersection operation. Let's take A to be a set. and this phi symbol is empty set. What happens when a set has a union operation with an empty set? It means when you are joining a set with an empty set, you will get the set itself. So A union phi will give you A. Then what happens in case of intersection? When you want to find intersection between a set and an empty set, you will result in empty set only. So intersection of set and empty set will be empty set, and union of set and empty set will be that set. So let's take option A. The first symbol is phi, which says it's an empty set. Empty set intersection, we have a set with empty set. This is almost similar to A intersection phi. So phi stands the same, and instead of A we have a set with empty set as described here. So what is the result of A intersection phi? It is phi only. Empty set intersection set with empty set will be empty set again. So A will be mapping to 1. We have two options of A mapping to 1. So we rule out 2 and 3. Now let's go for B. A set with empty set intersection a set with empty set. So both the sets are actually same. Let's take for example S1 is equal to the first set 1, 2 and S2 is equal to the second set that is also 1, 2. What is S1 intersection S2? It is 1, 2 again. What I am trying to tell you is when you have a set with empty set on both the sides, the intersection will also give you the same thing. This is also a set with an empty set. B is also mapping directly to option 2. Now let's take C. We have a set, and inside the set we have two elements. One is empty set and another is set with empty set. So this is one set together. We have difference operation with empty set. What is the result? If I take two sets S1 and S2, let's take S1 is equal to 1, 2, 3, 4. So this is one example. Let's forget this. Now this is the other example. S2 is equal to 1, 2. So whatever is present in S1 but not in S2 will be considered as the result of difference operation. So S1 and S2, when they are under difference operation, S1 minus S2, the result will be 3, 4. How will you take intersection for S1 and S2? Whatever is common, you will take it out. Now you have to remove the intersecting elements in order to perform the difference operation. So I am removing the intersecting elements and finding the difference will be 3, 4 elements inside the set. So what is this? We literally translate this. This is a set with two elements and this is an empty set. So let's take an example for this again. Let S1 is equal to 3, 4. S2 is equal to 1, 2. Now what will be S1 minus S2? When you have two different sets here without any intersection elements, the result will be S1. This is equal to 3, 4. Consider this to be a set with two elements and consider this to be a set with 0 element. So since you don't have any intersection elements here, you automatically output the S1 set totally. So which means the set will be represented as it is. The result will be the S1 set completely. C will be mapping to 4. Option number 4 has C4 and so we will rule out 1 also. Option number 4 will be the right answer. Why is C mapping to fourth one here? It is because this first set has two elements and the second set has 0 elements. So consider the same case here. S1 is equal to 3, 4 and just take S2 is equal to empty. We are not worried about what is inside S1 when S2 is empty. We just bring the answer of S1 minus S2 as S1 itself. A difference and empty set will again give A. So this is for union, this is for intersection and this is for difference. Now let's go for D. Empty set union and empty set inside a set and inside a set. This is empty set. This is an empty set inside a set. Then what about this one? So there are 3 sets totally. So let's take this to be first set, this one as second set, and this one as third set. The outermost set, the first set has 1 element, the second set, the middle set has 1 element, and the third set, the innermost set, has 0 elements. It means a set of set with empty set. These two are not equal. In this case, this particular symbol, this is equivalent to this one. Now they are asking for union. We need not go and inspect what is inside this set. Since empty set is given here and there is a union operation, consider this complete set as a single set, namely A. What is A union empty set? It is A again. So just output A again, which means I have to output only the right hand side of union operation. So this will be the answer. We are mapping D to 3. Whenever you see an empty set, remember these 3 and just apply them. So empty set intersection sum set. Consider this to be A. Empty intersection A will give you empty set again. A option is taking this. Coming to C, we apply this difference operation with empty set. For D, we use A union empty set. So using these 3 operations, we are just mapping A, C and D to the answer. Regarding B, it is just similar to this example. Let's take this to be S1 and let's take this to be S2. Since S1 and S2 have equal number of elements and the same element, we are just finding that element to be the intersecting element. Option number 4 will be the right answer. Next question. Match list 1 with list 2. Propositions have been given in list 1. The disjunctive normal form have been given in list 2. They are asking which is the DNF of which proposition. What is disjunctive normal form? It is obtained by operating or among variables connected with and. If we take all the options here, you can find or connecting the and. Here it is or, here it is or, here it is or, here it is or. Fourth and the second option will give you the exact meaning. Inside the brackets you have and operation and they are outwardly connected by or operation in option number 2. And if you take the fourth option, there are 1, 2, 3, 4 and operations connected by 3 ors. Operating or among variables connected with ands. So now let's get into the solving part. Let's start with C. P implies Q. What it is actually? Negation of P or Q. So here we can map C to 3 directly. So only 2 options are having C to 3. So we rule out 3 and 4. So here this negation is termed as one operation and or is placed outside. So that's why they have given in brackets. We'll go with A. P and P implies Q. Let's have P and what is P implies Q? Negation of P or Q. Now we'll apply this and inside the brackets. So this will be P and negation of P. The or will be staying as it is P and Q. So and connected by or. This is a DNF. So A is mapping to 2. From this we can say that option 1 is also ruled out. Option number 2 will be the right answer. Now let's get into D. The answer for D is 4. So we'll start with 4 and see whether we are able to get D. P and P or P and Q or P and R or Q and R. P and P is actually P. We'll just have it as P or P and Q or P and R or Q and R. So by absorption law, this will become P. So P, this R stays here. Then we have P and R or Q and R. Again, this is a form of absorption law. Using the same law, we are reducing this to P or Q and R. This is actually equivalent to D. So we are starting with option 4, the answer of D, and then arriving at D. So D is mapping to 4, it is right. So let's take this side. So negation of P or Q implies P and Q. Now we can solve this in two ways. One way is you have to apply the negation inside this particular part and then apply implies operation. The other way is treat this as P and this as Q. So I am going with this. What is P implies Q? Negation of P or Q, right? So negation of P means negation of the complete part of P or this Q, P and Q. Now we will first apply the inner negation, then we will apply the outer negation. Now let's apply this negation inside. Negation P, when I bring negation to OR, this becomes and then negation of Q or P and Q. And now I have to bring this negation inside again. So negation of negation P, and when I apply negation to AND, this becomes OR again, and then negation of negation Q or P and Q. Negation of negation P is P, or negation and negation of Q will give you Q or P and Q. You can just reduce this to Q by using absorption law again. We are reducing this to Q. So this is P or Q. B is mapping to 1. If you find your answer with 1 or 2 options, make sure the other options are also yielding the correct result to make sure that you have answered it right. Option A, B and C, we started from left side and we arrived at the right side. Option D, we have just done the reverse process. So option 2 will be the right answer. Next question. Given below are two statements. Statement 1. If H is non-empty finite subset of a group G and A into B that belongs to H, this is A into B that belongs to H for all A comma B that belongs to H. It means for all A comma B that belongs to H, then H is also a group. So to support this, we have a part. Let H be a subset of a group G. So this says a non-empty finite subset. H is called a subgroup if H itself is a group under the operation of G. So they have given some simple criteria in that if you take a subset H of a group is a subgroup if identity element E that belongs to H, it means H is non-empty. It is closed under the operation, that is if A and B belong to H as per this condition, then A into B belongs to H. This is what they have stated here. Using these 2 points, we can mark statement 1 to be true. They are saying if H is a subset of a group and it is closed under A into B operation, then H is also a group. This is what they say, a subset of a group is a subgroup. So subgroup in the sense it is itself a group under some operation. Then we will check the third point. H is closed under inverses. That is, if A belongs to H, then A inverse also belongs to H. Every group G has the subgroups, the identity element and G itself. Any other subgroup of G is called non-trivial subgroup. It was just a part of this explanation, so I took even this. It might be useful for you in some other question paper. So based on 1 and 2 points, we mark statement 1 to be true. Next, the second statement. There is no homomorphism that exists from Z plus to Q plus, where Z is a set of integers and Q is a set of rational number. Now you have to understand one concept. You have natural numbers starting from 1, the positive part, then the whole numbers that includes all natural number and 0. So 0, 1, 2, etc. Integers represented by Z, they have whole numbers as well as their negations. It means negative numbers are included, 0 is included, positive numbers are included. What are rational numbers? They are represented by the symbol Q. They can be represented as a fraction, 1 by 4, root 9, 0, then we have 0.999, 3.57. So anything that is represented as a fraction will be under rational number. What are they saying here is there is no homomorphism. What is homomorphism? It's a mapping between two structures of the same type. If you take G and H to be a group, so it is under this operation and H is under this operation. Just see how they are applied. This mapping is called a homomorphism. We have already solved some working problems in certain question papers where they will be asking us to find the homomorphism. But for this question, every integer is also a rational number, which says that Z is a subset of Q. It means the rational number is including the integers. Integers are including the whole numbers are including the natural numbers. So in this case, they say there is no homomorphism. It means there is no mapping. They have given addition operation under integers to addition operation under rational numbers. When I say 1 plus 1 is equal to 2, is it a part of Q? Yes. So there is a mapping. When they say Z is a subset of Q, it automatically means there is a homomorphism. There is a mapping. In one question paper, there was a function and we had two groups. Here we had 1, 2, 3, minus 1, minus 2, minus 3. And here this side we had only minus 1 and 1. When they are applied in this particular function, they gave only 1 and minus 1 as the answer. So if we take 1 here, 1 divided by mod of 1 will give you 1, 2 divided by mod of 2 will give you 1. All the positive mapped to plus 1 here and all the negative minus 1 divided by 1, minus 2 divided by 2 and minus 3 divided by 3 gave you minus 1. All the negative mapped to minus 1. They say using this function there is a particular mapping. This was a previous year question. I just took it for an example. So here it is addition. They have placed Z here. So any number 0, 1, 2, 3, minus 1, minus 2, minus 3, anything can be taken and here it is a set of rational number. So you include 0, 1, 2, 3, you include minus 1, minus 2, minus 3, you include even 0 point something or 1.3, you have roots. When they say there is an addition operation, it automatically has a mapping in the rational numbers addition to. When I say 3 plus 3 is equal to 6 in rational numbers context, I can say it is 6.0. So there is definitely a homomorphism that is existing from integer addition to rational number addition. So statement 2 is marked as false. Option number 3. Statement 1 is correct but statement 2 is incorrect will be the right answer. From here, we are going to solve the next 5 questions. This is based on linear programming. All this time we were using x plus y plus z is equal to some 20 or 30. Then we had some constraints with inequalities. Then they say x comma y is greater than or equal to 0. They will give you the equation and they will ask you to find some solution. This was the case so far we have been seeing in UGC net question paper. But in actual class of linear programming, this is how the class will be starting. They will give you a scenario and they will ask you to find the linear programming problem itself. And from the problem, you will be finding the solution. That will be the next stage. So usually they will give you in terms of x and y and they will ask you the solution alone. But this time they are asking you to frame the equations, frame the problem and then find the solution. We will do it now. Before answering the 5 questions, first let's understand what the question is about. Food X contains 6 units of vitamin D per gram and 7 units of vitamin E per gram. Cost is rupees 12 per gram. Food Y contains 8 units of vitamin D per gram and 12 units of vitamin E per gram and cost is rupees 20 per gram. The daily minimum requirements of vitamin D and E are 100 units and 120 units respectively. Suppose X is quantity in gram of food X and Y is quantity in gram of food Y. So they are representing small x as the quantity of food capital X and small y as the quantity of food capital Y. Answer the following question based on the above paragraph given. First, let's convert this into a tabular form so that using the table we will be able to form the linear programming problem or the necessary equations. So let's make a table now. I have created 4 columns. First column will be food. So there are 2 types of food. One is food X and another is food Y. Both the foods are having vitamin D and vitamin E. How much vitamin D is present in food X? It is 6 units. So we'll place 6 here. How many units of vitamin E are available in food X? It is 7 units. And what is the cost per gram? It is 12. So everything is given for per gram. Now let's go to food Y. How much vitamin D is present per gram? 8 units. And how much vitamin E is present per gram? 12 units. And what is the cost? It is rupees 20 per gram. So there are two foods, but we have a minimum requirement of this much vitamin D should be there and this much vitamin E should be there every day, and those vitamins will be taken by taking these two foods X and Y. So now the minimum requirements of vitamin D will be 100 and minimum requirements of vitamin E will be 120. We are representing the equation in terms of X and Y. So this X will represent the food X quantity and this Y will represent this food Y quantity. These are the details we can get from this question. Now we will start answering the question. The cost function of total food is. Where do you actually find the cost is in the fourth column. The cost is given as 12 for food X and 20 for food Y. And they have told that small x is used to represent the food capital X and small y is used to represent the food capital Y. Whenever you take a linear programming problem, it will be usually mentioned in the form of maximization function or minimization function. There will be variables like x, y and sometimes z that will be equating to some value. So this will be the form. What is the cost for food X? It is 12. So 12 into small x plus what is the cost for food Y? 20 per gram. So 20 into small y. And we usually assign capital Z for these kind of functions. Cost function will be 12x plus 20y. This is from food X cost and this is from food Y cost. This is how you will be framing the cost function from the above given data. Option number 3, Z is equal to 12x plus 20y will be the right answer. Next question, which of the following constraints when formulating the LPP? When you frame a LPP, you will first have Z is equal to some equation. After that, you will be given some constraints. There will be 2 or 3 constraints depending on the number of variables. These constraints will have inequalities. Inequalities in the sense they will either be represented as less than equal to or greater than equal to, and the variables will be represented as greater than or equal to 0. Now the question is about what are the constraints for this particular LPP. Based on this only, we are going to frame the constraint. There are two foods, food X and food Y. While forming the constraints, you have to go column wise. We found the cost function from the cost column. Similarly, we have to pick the constraints from the vitamin D column and vitamin E column. Now, the representation of food X will be small x and representation of food Y will be small y. Since there are two variables, there will be two constraints as for this question. Equation will be 6x plus 8y. The previous question we equated it to z because it's a cost function that we have to find since there is no value here. Now they have given a value called 100. So we'll place this here. What kind of inequality will you place here? Whether it is less than or equal to or greater than or equal to. So now let's read the statement again. The daily minimum requirements of vitamin D and E are. If minimum requirements means, if they say 100 is minimum requirement, it means greater than or equal to 100. If they say 120 is the minimum requirement for vitamin E, it means it is greater than or equal to 120. So the values will be like 100, 101, 102 and it goes on. Here the minimum requirement is 120 for vitamin E. It means it starts from 120, 121 and it goes on. We will represent 100 and more as greater than or equal to 100. Why do we include equal to symbol here is the minimum is given as 100. So it will be greater than or equal to. Either it will be 100 or more than 100. Similarly, we will place greater than or equal to 120 because it is either 120 or more than 120. In that case, 6x plus 8y should be greater than or equal to 100. Now the vitamin E equation will be 7x plus 12y is greater than or equal to 120. Remember, this is for vitamin D and this is for vitamin E. Now they are asking the values of x and y. X is the quantity in gram for food X and Y is the quantity for food Y. Now they have some kind of minimal requirement of vitamin D and E and they have given only two foods. It means you have to take some quantity of food X and some quantity of food Y. Say in binary you have two values. 0 means it is a no, 1 means it is a yes. If I say 0 in binary, it means I am not taking that food. If we say 1, it means we are taking the food. But here in usual discrete form, if we say 0, it means it is of 0 quantity. If we say 1, it means a count of 1 and it goes until how many ever units it is available they can take. X is going to have some 10 value means the count will be 10. The value of x will be starting from 0 and it will be more than 0. If we say 0 means you are not going to take food x. If we say 1, you are going to take 1 unit of food x. So in that way, you can either take the food or leave the food. In the sense, sometimes you will have only food y. You will have the requirement of 100 and 120 means it's more than enough. So there can be a case where the values can be either 0 or more than 0. So in this case, x can be greater than or equal to 0 and y can also be greater than or equal to 0. This is actually represented as x comma y greater than or equal to 0. Now we will find which constraints are available in this option. So first option is saying it is less than or equal to. So whichever has less than or equal to, you can rule out the option because your minimum requirement gives a condition it is greater than or equal to. Third option says that 6x plus 7y. 6 belongs to food x and 7 also belongs to food x only. But y is representing the food y. When you are talking about the minimum requirement of D, you have to look at this column for x and y and not row wise. So this equation is also wrong. Similarly, you can check 8x plus 12y. They have just computed row wise which is wrong again. Now let's see option 4. 6x plus 8y as we got here greater than or equal to 100. 7x plus 12y greater than or equal to 120. And x comma y greater than or equal to 0. So all these three are present. Option number 4 will be the right answer. In case the question is daily maximum requirement, then what will be the inequality is less than or equal to. Say for example, if maximum is 200, the equation will turn as less than or equal to 200. So when you represent equal to, it is equation. When it is less than or equal to or greater than or equal to, these are called inequalities. Next question. Which of the following are quantities? The value of x and y of food x and y respectively when the cost of food is minimum. Whenever you go for buying something, we always demand that we pay less. So when cost is involved in some problem, we will often end up with minimizing the cost. So in this way, when cost is available here, the problem will be taken to be minimization problem only. So in that aspect they have given when the cost of food is minimum. So we have to find the values of x and y. So there are two ways to find x and y. The first way is using the graphical method and the second way is using Simplex method. Regarding graphical method, I will tell you now, and once we find the answer for this question, I will also explain you the same problem using Simplex method because this Simplex method will use a method called Big M. In the previous session question papers, we have solved using graphical method, we have solved using Simplex method, but so far we have not tried Big M. So this question I will solve it in graphical as well as Simplex method, so watch out. So what we will do for graphical method is usually we will take the constraints. So what are the constraints available? 6x plus 8y greater than or equal to 100. Then we have 7x plus 12y greater than or equal to 120. These two constraints are there. Then we have x comma y greater than or equal to 0. Usually in graphical method, we will make one of the variables value as 0 and then find the other value. From one equation we will get two pairs of value, then from another equation we will get two pairs of value. In a graph we will plot all the four values and find some intersection point. That intersection point will give you a x value and a y value. So totally you will have 5 pairs of solution. From them we have to calculate this cost. So let's take the first equation, 6x plus 8y is equal to 100. So how did this inequality change to equality is, basically we will convert this into an equation and then only apply 0. See, if I apply 0 in x directly here, it is 0 plus 8y greater than or equal to 100. From this I will not be able to calculate a value for y. So this is the usual method we follow. Now we will place x is equal to 0. This will make 8y is equal to 100 and y is equal to 100 divided by 8. This will give a value of y is equal to 12.5. From 6x plus 8y equal to 100 we get 0, 12.5. Now we will make y to be 0. So we will have 6x is equal to 100 and x is equal to 100 by 6. You will have 50 by 3. This will be around 16.67. So here the next coordinate here will be, it is 60.67 comma 0 or 50 by 3 comma 0. Even this coordinate can be, instead of having 12.5 we can say it is 12 into 1 by 2. Now from the next equation, 7x plus 12y equal to 120. So first we will make x to be 0. So 12y is equal to 120. From this we can have y is equal to 10. So 0 comma 10. Next we will make y is equal to 0. From this we will have 7x is equal to 120, x is equal to 120 divided by 7 and x is equal to 17.14. So here it is 17.14 comma 0 or 120 by 7 comma 0. So we have 4 coordinates totally. We will get into plotting now. Let's take the first equation, 6x plus 8y is equal to 100. So we have 2 points there. The first point will be 0, 12.5. The second point will be 16.67, 0. So when we want to calculate the cost function, at that time we will use 50 by 3, the fraction part. But in order to plot in the graph, we will need a decimal point. That's why I have mentioned both the forms here. So this will be 16.67, 0. In a coordinate x, y, when x is 0, the point lies on the y-axis, and when y is 0, the point lies on the x-axis. Make sure that you are plotting it properly. We will get into the second equation, 7x plus 12y is equal to 120. We have 2 points again. The first coordinate will be 0, 10 and the second one will be 17.14, 0. We have to draw a line for these 2 points, 0, 12.5 and 16.67, 0 are just connecting here. And now we have to draw a line for these 2 points, 0, 10 connecting to 17.14, 0. Now we have a intersection between these 2 points. Let's see what it is. So this intersection point is somewhere around 15 in the x-axis. So let's take x-axis value as 15 here, and this is somewhere between 1 and 2. So we can see the second option of this question as 15 and 5 by 4. As for now, let's take this 5 by 4 as approximately to 1.2. Y-axis value will be 5 by 4. So we have the intersection point here, namely 15, 5 by 4. We will retain the fraction part because we will need it to calculate the cost function ultimately. Now regarding the graphical method, there is something called feasible region that you will be able to visually see in the graph. How will the feasible region be for maximization problem and minimization problem? Let's take this to be a graph and this to be some intersecting point. For maximization problem, the feasible region will lie below the line. We have the values x greater than or equal to 0 and y greater than or equal to 0, which is this part. And when those equations are solved and we plot two lines, the intersecting part or that region will be marked above the 0th point in both x and y axis as well as below those lines. This is the case of maximization. What about minimization? In minimization, this becomes the minimum requirement as they mentioned in the question. Since it is minimum, this particular line will be the starting point of the feasible region. So this will be for minimization problem. So let me draw separately and show where the feasible region will occur. Now we will mark the feasible region's boundary in a different color. So I have used green here. So after this, everything will be the feasible region. So what points are involved in this feasible region? We have one point here, we have the other point here and the other point here. So 3 points are involved. Just take 0, 12.5 can also be written as 12 into 1 by 2. And then we have 15, 5 by 4. Then we have 17.14 is otherwise mentioned as 120 by 7, 0. So these 3 points are called critical points. We need not get into the details of graphical method. I am just trying to tell you how to solve it. So we have 3 points here. What is the cost function that has been given in some previous question? It is z is equal to 12x plus 20y. Now they are asking when the cost of food is minimum. So you have to find where it is minimum. Option number 1 is present here. Option number 2 is present here. Option number 3 is present here. Before calculating option number 4, we can find that it is not a part of the critical point. It is not falling in the feasible region part. So we can easily say fourth one will not be an option. So what happens if we calculate fourth one in case without drawing this graph? I'll just tell you what happens and why we have to rule it out earlier itself. So let's first calculate z for the rest of the options. 12 into x, so 12 into 0 is 0 plus 20 into 12.5. This will give a value of 250. So let's mention 250 here. Then we have 15 as x value. So 12 into 15 plus 20 into the y value is 5 by 4. Here 12 into 15 it gives 180 plus I will cancel 4 and 20, 4 5s are 20. So 5 into 5 is 25. This gives a value of 205. Now we have 120 by 7. So since y value is 0, 12 into 120 by 7 will result in 1440 divided by 7, which is equal to 2.5.7 and it goes on. So for now we will take it only with regards to one decimal point. So in order to differentiate option 2 and 3 we have 0.7. Then for 0, 10, why did I rule it out in the beginning itself means it's because of this. 0 into 12 will give 0, 20 into the y value 10 will give 200. Now if you consider only these 4 options and calculate the cost using this particular objective function, what will happen is you will end up marking option 4 as the right answer because the cost of food is minimum only in option 4. But the reality is you should never consider this point because when you take feasible region, you have to take only the critical points into calculating the z value. That's why I ruled it in the beginning itself. Now 250, 205, 205.7, which is lesser, option 2 is lesser. From this we can say option 2 will be the right answer. So x is equal to 15 and y is equal to 5 by 4. From here we get a cost of 205. Out of these 3 critical points we find that this cost is minimum. So we have got the value of x and y through this graphical method as 15 and 5 by 4 respectively. This is how we will be doing graphical method. Now we will proceed with the simplex method to solve the same problem, and let's check how we are ending up with the x value and the y value along with the cost value. So z is equal to 12x plus 20y. Then we have constraints 6x plus 8y greater than or equal to 100. Then we have 7x plus 12y greater than or equal to 120. Then we have x comma y greater than or equal to 0. So we will start. The ultimate aim of this z is to find the cost of food whichever is minimum. So here this is a minimization problem. From the question we are deriving, it's a minimization problem. First we have to convert the inequalities to equalities. How will we do this? So 6x plus 8y. If the inequality is going to be less than or equal to some value, then we will usually add a surplus variable. Since the constraint is having greater than or equal to inequality, we are going to subtract the surplus variable from the equation. So 6x plus 8y is going to be greater. So I am subtracting a surplus variable and equating this to 100. Similarly, 7x plus 12y. So in order to have no confusion, I am taking the surplus variable as s1 and this to be s2, and this is equal to 120. So when you have 6x plus 8y less than or equal to 100, this will be 6x plus 8y plus s equal to 100. Okay, so what inequality is present here, based on that only you have to add or subtract the surplus variable. So this is not related to this question, so even then I am telling you for your information. And since we have used two surplus variables here, we will call them as negative slack variables also. We are including it in z. So z is equal to 12x plus 20y. We have to use the coefficient value as 0 because they are not a part of the original problem. We are only including it. So it is 0 into s1 plus 0 into s2. So minimize z is equal to, then we will say subject to these two constraints together. And from here we can say x and y is greater than or equal to 0, and s1 and s2 both should be greater than or equal to 0. Whenever we want to find a basic feasible solution from surplus variable placed equations, we will always make x and y to be 0, and then we will find the value of s1 and s2. In this case, making x and y to be 0, we can find s1 is equal to minus 100 and s2 is equal to minus 120. When you have negative variables for surplus variables, this will be an infeasible solution. Whenever you have an infeasible solution, you have to introduce artificial variables. I am not writing all the details about this problem in words, but I am talking. So please listen to what I talk. Whenever we want to find a basic feasible solution from the equation like this, we have converted inequality to equations. இந்த மாதிரி convert பண்ண equationsக்கு நம்ம basic feasible solution கண்டுபிடிக்கணும்னா x and y ஓட வேல்யூவை at a timeல 0ன்னு மாற்றணும். அப்படி மாற்றிட்டீங்கன்னா உங்களுக்கு s1 and s2 ஓட வேல்யூ என்னன்னு கிடைச்சிடும். யூஸ்வலி லெஸ் தென் ஆர் ஈக்குவல் டு போட்டு நீங்கள் s1 s2 யூஸ் பண்ணிங்கன்னா உங்களுக்கு பாசிட்டிவ் வேல்யூவாக தான் வரும். பட் இங்கே நீங்கள் மைனஸ் s1 மைனஸ் s2ன்னு போட்டிருக்கிறதுனால எக்ஸ் அண்ட் ஒய்யை நீங்கள் ஜீரோவாக மாற்றினதுக்கப்புறம் உங்களுக்கு s1ஓட வேல்யூ வந்து மைனஸ் 100னும் s2ஓட வேல்யூ மைனஸ் 120னும் வரும். If this is the case, we call them as infeasible solution. When we get negative values for surplus variables, we term the solution as infeasible solution. In this case, we are introducing artificial variables. For artificial variable, now I use a1 and a2. So why I am using two variables? There are two equations. So how will this equation be converted now? It is 6x plus 8y minus S1. In order to make this value positive, I am going to add the artificial variable as plus A1, which is equal to 100. Similarly, the second equation, 7x plus 12y minus S2 plus A2 equal to 120. This will be the case. Now when you try to find a basic feasible solution, so I'll mark it as basic FS, we have to make everything as 0, and from this we can get A1 is equal to 100 and A2 is equal to 120. Making everything 0, we are finding this. So when we have such positive number, it means this is a basic feasible solution. Since we have introduced two artificial variables, now we have to insert this in the objective function minimization function. Minimize z is equal to 12x plus 20y. Already we have 0s1 plus 0s2. Now we have introduced two artificial variables also. So we are placing a1 and a2. What are the coefficients of a1 and a2? This a1 and a2 will have large value like 10,000, 1 lakh. It will have large value. The large value will be represented as m. To represent them in coefficient form, we can have plus m and plus m. So this m can be something, a value like 10,000. So let me explain in Tamil for Tamil subscribers. Basic feasible solutionல surplus variableக்கு negative value வந்துருச்சு. நம்ம artificial variables ன்னு சொல்லிட்டு ஒரு equationக்கு ஒரு artificial variable introduce பண்றோம். So first equationல place பண்ற artificial variable a1 னும் second equationல place பண்ற artificial variable a2 னும் சொல்றோம். இப்படி செய்யறப்ப நம்ம இதுக்கு basic feasible solution இப்ப கண்டுபிடிக்க போறோம். So இதுக்கு கண்டுபிடிக்கிறப்ப எல்லாத்தோட வேல்யூவும் 0வா மாத்துறப்ப நமக்கு a1க்கு வந்து 100 னும் a2க்கு 120 னு பாசிட்டிவா வந்துருது. a1 and a2 will be greater than or equal to 0. This becomes the basic feasible solution. எப்பவுமே நம்ம inequalitiesல என்ன வேரியபிள் ஆட் பண்ணாலும் அதை வந்து நம்ம objective functionல include பண்ணிக்கிட்டே இருக்கணும். So whenever we include any kind of variables in the constraint equations, we should always include them in the objective function too, the minimization function too. So for surplus variables, we introduce the coefficient called 0. But for artificial variables, we have to use m. இந்த m ஓட representation என்னன்னு பார்த்தீங்கன்னா, இப்போ நான் 10,000 இல்ல 1 lakh இந்த மாதிரி பெரிய நம்பரை தான் வந்து artificial variablesக்கு coefficient நம்ம வைக்கணும். So இதனால தான் நம்ம வந்து இதை big M methodனு சொல்றோம். So since we use capital M here, we call this method to be big M method. This is a minimization problem. The objective function should be in form of maximization problem. So in order to convert minimization to maximization, we have to multiply the objective function by minus 1. So z is equal to minus 12x minus 20y. Then for 0, there is no use of saying it is plus 0 or minus 0. So let it stay as plus 0s1 plus 0s2. And m is a very big number. So we will have minus m into artificial variable 1 and minus m into artificial variable 2. You can ask me whether I can place the same m again and again. This is just a coefficient. This is not going to have any big role here other than to solve the problem. So there is nothing wrong. நீங்க மினிமைசேஷனை மேக்ஸிமைசேஷனா கன்வெர்ட் பண்ணோம்னா z ஃபங்க்ஷனை வந்து நீங்க -1ஆல மல்டிப்ளை பண்ணிக்கோங்க. இது ரெண்டு இடத்துலயும் வந்து s1க்கும் s2க்கும் கோஎஃபிஷியன்ட் 0வா இருக்கிறதுனால அதுல நீங்க வந்து மைனஸால அப்ளை பண்றதுனால ஒரு யூஸும் இருக்க போறதில்ல. அதனால அந்த 0 is staying as it is. Now we will get into the solving part. So the basic variables x, y are here from the equation. Then we have s1 and s2, the surplus variables. Then capital A1 and capital A2, which are the artificial variables. The row that is top to the basic variable. So what is the x coefficient? Minus 12, it is placed here. Then y coefficient is minus 20. S1 and S2 are 0. Then for A1 and A2, it is minus m, we have placed here. Now we have to start with artificial variables as the basic variables. The reason is we have got the basic feasible solution for these two values. Usually in the problems we will start with surplus variables, but in this case Surplus variables have resulted in infeasible solution. So we introduced artificial variables. In the sense, these two will be taken as the basic variables as of now. The coefficient of A1 and A2 will be in the left side column as minus m. Now we will get into the table. First constraint 6x plus 8y. So here the value is 6. Here the value is 8. S1 it is minus S. So in this case it is minus 1. Is there S2 variable in the first equation? There is no S2 variable. So we will place it as 0. A1's value will be plus 1 because it is plus A1. A2 is not present in the first equation. What is the right hand side? It is 100. Now we will place the second equation. 7x plus 12y. We don't have S1 here, so it is 0. We have minus S2, it is minus 1. A1 we don't have here. A2 the value is 1. The right hand side will be 120. We have to find the pivotal element. So we have to see which is entering, which is leaving. All these stories I have already explained in another video. So next we have to find Cj minus Zj or Zj minus Cj. So let me tell you how to do this. X into Cb plus y into Cb, the particular coefficient, minus the z value. This is what they meant as Cj minus Zj. So here it is 6m and here it is 7m. Of course it is minus 6m and minus 7m, and it is minus 12 here. They have usually given in the form of Zj minus Cj. So Zj minus 12 will stay like this, and minus 6 and minus 7 will give you minus 13m. So minus of minus 13m will give plus 13m minus 12. So let's not take it this way. So let's take it as Zj minus Cj. Okay. So the value here is 13m minus 12. Now we will calculate for the next column. It is minus 8m and minus 12m, giving a value of minus 20m, then minus 20. So minus 20 minus into minus 20m will give plus 20m. This is 20m minus 20. Now the next calculation, minus 1 into minus m. Minus 1 into minus m will give you capital M. Then you have to go Z minus C. So here it is 0. 0 minus the positive m will give you minus m here. The same value will be applicable here also. Here you have 1 into minus m. So 1 into minus m will give you a value of minus m. And here it is minus m minus of minus m. So minus m plus m will give you 0 ultimately. So here also you will have 0. So which is the largest value here? This is the largest value. Capital M has a value of 10,000 and more. Which has the largest value? It is this one. This will be the column that we are going to consider as of now. Now we have to find the ratio here. 100 divided by the particular value 8, and here it is 120 divided by 12. 100 divided by 8 is 12.5, and 120 by 12, this will give 10. So which is minimum here? Of course 10 is minimum. So this will be the leaving variable and this will be the entering variable. The intersection will be the pivot element 12. Y enters and A2 leaves. Y enters because it has the highest value and A2 leaves because it has the lowest value. When you take Cj minus Zj, the smaller value should be considered. When you take Zj minus Cj, the higher value or the larger value should be considered. Here we have taken Zj minus Cj, so we are going with the higher value. இப்போ நம்ம Cj minus Zj வச்சு calculate பண்ணியிருந்தோம்னா எது இந்த particular rowல வந்து least-ஆ இருக்கோ அதை நம்ம choose பண்ணியிருக்கணும். பட் நம்ம Zj minus Cj போனதுனால எது highest-ஆ இருக்கோ அதை choose பண்ணுறோம். Actual equation வந்து Cj minus Zj தான். So the entering element instead of A2, who should enter here? Y is entering and A2 is leaving. Then we will have A1 here as it is. The coefficient of A1 will be minus m as per the objective function. The coefficient of y will be minus 20 in the objective function. I have to make this particular place as 1. இங்க என்ன பண்ணா எனக்கு 1 கிடைக்கும்? I can divide the particular row by 12 in order to get 1 here. This is the old A2 row I have taken. 7, 12, 0, minus 1, 0, 1, 120. Now I have to divide this particular y by 12. This is the new row that I am going to place. So I will get 7 by 12 and 12 by 12, which is equal to 1. 0 by 12 is 0, minus 1 by 12, then 0, again 1 by 12. 120 by 12 will give me a value of 10. Now I will place this here. 7 by 12, 1, then 0, then I have minus 1 by 12, then I have 0, then I have 1 by 12, then here 10. I have got this. The element that is in the same column should be 0. It means I have to make this particular value 0 in the next iteration. So this is the next iteration we are working. Maybe the first iteration or the next iteration. So in this I have to make this value as 0. Old row of A1. I have placed 6, 8, minus 1, 0, 1, 0 and 100 here. Now I have to make this 8 as 0. So what I will do is minus 8 into the new y value. Minus 8 into the new y value is 7 by 12. So 4 2s are and 4 3s. So minus 14 by 3. So this is minus 14 by 3. Minus 8 into 1 will give me minus 8. Then I have 0 here. Minus 8 into 0 will give me 0. So this is the new y. I have to multiply this by minus 8. That computation only I am doing here. Then I have minus 8 into minus 1 by 12. So minus 8 into minus 1 by 12. 2 4s are and 3 4s are. So it is plus 2 by 3. Then 0 into anything is 0. Then I have minus 2 by 3. Because it is same 1 by 12 only, I have to just include the minus. Here we have 10. So 10 into minus 8 will be minus 80. Now if you add this old A1 plus minus 8 into new y, if you add these two rows, we will get 0 here. So this is the ultimate aim of doing all such calculations. Minus 1 plus 0 is minus 1. 0 plus 2 by 3 is 2 by 3. 1 plus 0 is 1. 0 minus 2 by 3 is minus 2 by 3. 100 minus 80 will be 20. I am not subtracting. I am using here minus 8 and I am just adding this. So 6 minus 14 by 3. So 6 into 3 it is 18. 18 minus 14 by 3 will give 4 by 3. So this is my new A1 row. So it is 4 by 3. I am placing here. It is 0. Then I have minus 1. Then it is 2 by 3. Then it is 1. Then it is minus 2 by 3. Then we have 20 here. Now again we have to find Zj minus Cj and find whichever is higher. Remember Cj minus Zj it is smaller value. Zj minus Cj it is higher value. So let's calculate Zj minus Cj. Let me make the computation here. It is minus 4m by 3. Then minus 20 into 7 by 12. 4 3s are and 4 5s are. It is minus 4m by 3 minus 35 by 3. If both are going to be minus, I have to convert this as plus because this is C. So Zj is minus 12. So minus 12 plus 4m plus 35 by 3. And if I take LCM, it is minus 36 plus 4m plus 35 by 3. 35 minus 36 is 4m minus 1 by 3. It is 4m minus 1 by 3. I can write this as 4m by 3 minus 1 by 3. After the iteration, I will remove the calculation because I have to further calculate in the same space. 0 into minus m is being given, so it is 0. Then 1 into minus 20 is minus 20. Then we have minus 20 here in z. So z minus of minus 20 will give plus 20, which is equal to 0 here. Minus 1 into minus m is m. Then we have 0 here. Then we have 0 here. This will ultimately give minus m. Then we have 0 again. So whatever value you get, you have to put it in negation only. So it is minus 2m by 3 plus 20 by 12. So 4 5s are and 4 3s are. It is 5 by 3. So you have to just reverse the symbol here because you are going to put it in negation. I will get 2m by 3 minus 5 by 3. Then it is 1 and 0. So this is going to be minus m and this is going to be another minus m. So minus m plus m will give you 0 here. Then the same fraction with the exchange of symbol. It is minus 2 by 3 into minus m will give you 2m by 3. Then 1 by 12 into minus 20 will give minus 5 by 3. So we have to change the symbol. So let me write it in the top. It is minus 2m by 3 plus 5 by 3. Then this minus m will stay. Now when you find LCM, this will be minus 3m minus 2m divided by 3. And this is plus 5 by 3. So minus 3 and minus 2 will give minus 5m by 3. So in this we will get 5 by 3 minus 5m by 3. For RHS we need not calculate. We have to find which is higher here. This is in minus, so A2 will not have any modification here. 2m by 3 is present and 4m by 3 is present. Which is higher? So this is 1 point something and this is 0 point something. In this case, this particular value enters. So we are going to consider only this. So x is entering. Now we should see which is leaving. Obviously A1 should leave. Let's check. So 20 divided by 4 by 3, which will be 20 into 3 by 4. So 4 into 5, this will give a value of 15. This will be 10 divided by 7 by 12, which is 10 into 12 divided by 7. This is equal to 120 by 7. So we have already calculated 120 divided by 7 will be something in 17.14 or like that. So which is lesser here? 15 is lesser. So A1 is leaving. So we can say X enters and A1 leaves. So which is the pivotal element here? It is 4 by 3. We will have X here and Y will be here. We have to make this part to be 1. 4 by 3 can be made 1 only when we multiply it by 3 by 4. We will get into the next calculation. So this is 4 by 3, 0, minus 1, 2 by 3, 1, minus 2 by 3, 20. The row A1, old A1. 4 by 3 into 3 by 4 will give me 1. See, 4 by 3 into 3 by 4 will give me 1. Then 0 into 3 by 4 will give me 0. Minus 1 into 3 by 4 will give me minus 3 by 4. 2 by 3 into 3 by 4 will give me 3 get cancelled. 2 2s are 4. So it is 1 by 2. Then 1 into 3 by 4 will give me 3 by 4. Minus 2 by 3 into 3 by 4. Just a minus for this answer. So it is minus 1 by 2. Then we have 20 into 3 by 4. This will give a value of 15. We will have 1, 0, minus 3 by 4, 1 by 2, 3 by 4, minus 1 by 2, then 15. What is the coefficient of x in the objective function? It is minus 12 and y it has minus 20. Now as usual you have to find the new y. So now the old y is 7 by 12, 1, 0, minus 1 by 12, 0, plus 1 by 12 and 10. The only way to make this particular value 0, what we should do is we have to bring minus 7 by 12 here and then do a addition. Only then we can make it to be 0. So what we will do is we have to multiply minus 7 by 12 to the new x value. 1 into minus 7 by 12 will give you minus 7 by 12. When you add this, you will have 0 here. Y plus minus 7 by 12 x. 0 into something will give you 0. So there is no change. Then we have minus 3 by 4 into minus 7 by 12. So you have to cancel this. 1s are and 4s are. It is plus 7 by 16. Then we have 1 by 2. 1 by 2 into minus 7 by 12 will give minus 7 by 24. Then we have 3 by 4. So 3 by 4 into minus 7 by 12 will result in minus of 7 by 16. So here this is minus and this is minus. So we are inserting a plus. But here it is plus and this is minus but the same value. So we are giving a minus here. This time you have to negate the sign again. So 7 by 24 in positive. So plus 7 by 24. Then we have a value 15 here. So 15 into 7 by 12. And we have a minus of course. 3 5s are 15. 3 4s are 12. So it is minus 35 by 4. Now you have to add this. So adding this we have already resulted in 0. 1 plus 0 is 1. 0 plus 7 by 16 is 7 by 16. Minus 1 by 12 minus 7 by 24. If we take LCM this becomes 2 and it is minus 9 by 24 and minus 3 by 8. Then we have minus 7 by 16 and here it is 1 by 12 plus 7 by 24. It is 2 times to bring it to 24. So 9 by 24 is again 3 by 8. Now what is 10 minus 35 by 4? So 4 tens are 40. 40 minus 35 divided by 4 will give you 5 by 4. We have got the new y. So it is 0, 1, 7 by 16, minus 3 by 8, minus 7 by 16, 3 by 8 and 5 by 4. X is equal to 15 and y is equal to 5 by 4. We will complete the problem. Minus 12 plus 12 will give you 0 here and minus 20 plus 20 will give you 0 here. We have minus 12 into minus 3 by 4, then minus 20 into 7 by 16. 4 3s are 12. This is 9 minus 4 4s are 16 and 4 5s are 20. 9 minus 35 by 4. 9 4s are 36. 36 minus 35 by 4 will give 1 by 4. But you have to put it in negation form because it is 0 minus the value. So we will write it as minus 1 by 4. Then we have 1 by 2 into minus 12. So 1 by 2 into minus 12 will give you minus 6. Then we have minus 3 by 8 into minus 20. So 4 2s are 4 5s are. So it is 15 by 2 and it is in positive. When we calculate this it is minus 12 plus 15. It is 3 by 2. Since you have to negate it, it is minus 3 by 2. And here you have minus 9. Because it is plus 9 here it is only one symbol, so minus 9, and here it is plus 35 by 4 and it is minus 1 by 4 minus m 1 by 4. Here it is plus 6 minus 15 by 2 it is minus 3 by 2 and you have to make it positive. So it is already in minus, so I have to make this as plus. Now here it is in negation form, so it is plus 3 by 2 and minus m will stay. This is more important now. 15 into minus 12, you have nothing on top. All you have to calculate is this, plus 5 by 4 into minus 20. Now just multiply this. This is minus 180 and this is 4 5s are 20. So it is minus 25, which will give a value of minus 205. For negative function, you have got minus 205 as the answer. This is actually like minus z only. So z will have a value of plus 205. Why we have come to minus 205 is because it's a minimization problem. We have converted into maximization by multiplying it with minus 1. So basically this minus indicates that it is a minimization problem and z value is 205. So from this, x is equal to 15 and y is equal to 5 by 4 and z value is 205. This is the cost of food. Let me give you a recap of everything. We are having a minimization objective function. We have constraints with greater than or equal to inequalities. Now to convert the inequalities to equation, we are introducing surplus variables. Since it is greater than or equal to, we are using negation of the surplus variables, minus s1 and minus s2 in the equations respectively. From this, we are trying to find the basic feasible solution and we are ending up with negative values, which makes this to be infeasible solution. If we have infeasible solution in this case, we have to introduce artificial variables. So we are adding the artificial variables and then equating the equation to 100 and 120 respectively. Again finding the basic feasible solutions, we are ending up with a1 is equal to 100 and a2 is equal to 120 as the basic feasible solution. Regarding the objective function, since we have introduced two kinds of variables in the constraint equations, namely the surplus variables and artificial variables, we are bringing it to the objective function too. And in the objective function, we are placing 0 as the coefficient for the surplus variables and big M as the coefficient for artificial variables. The value of big M will be very large. That's why this method holds the name big M method. Since it's a minimization problem, we are converting it into maximization by just negating the objective function. Since there is no use negating 0, we are just placing 0 as it is. Rest of the coefficients 12, 20 and the big M all are converted to minus value. So minus 12, minus 20, minus M and minus M again for A2 here. So we are starting with a negated objective function and in the final iterations we are ending up with 0, 0 here. Since we need only x and y values, we have got it here. And moreover, there are no positive values here. Everything is negative. See, this is negative, this is negative. 1 by 4 is going to be 0.25 only. Minus 10,000 plus something will give you minus only. So this is also negative and this is also negative. We are calculating for Zj minus Cj. We have to go for the higher value and since all are negative, we are ending the sum with this iteration and ultimately we have got the values of x and y also. From this x and y, we are calculating the objective function value to be minus 205. Since it's in a minus form, it is minus 205. From this, we take the value of z is equal to 205. Since it's a minimization problem, we are ending up with a minus value. And since we have negated the objective function, we are ending up with a minus value. Let me once again repeat this in Tamil. நம்மகிட்ட வந்து ஒரு minimization problem இருக்கு. ரெண்டு greater than or equal to constraints ஓட இருக்கு. இப்போ நம்ம அந்த இன்இக்வாலிட்டிஸ் ஈக்குவாலிட்டிஸாக மாற்றணும்னா நம்ம சர்ப்ளஸ் வேரியபிளை இங்கே மைனஸ்னு போட்டு மாற்றிருக்கோம். ஏன் மைனஸ் போட்டிருக்கோம்னா இங்கே கிரேட்டர் தென் ஆர் ஈக்குவல் டு சிம்பிள் இருக்குது. அதுலேருந்து நம்ம பேசிக் ஃபீஸபிள் சொல்யூஷன் எடுக்கிறப்ப நமக்கு S1 அண்ட் S2க்கு நெகட்டிவ் வேல்யூ கிடைக்கிறதுனால அது இன்ஃபீஸபிள் சொல்யூஷன் ஆகிடுது. அந்த இன்ஃபீஸபிள் சொல்யூஷன் இருக்கிறதுனால நம்ம ஆர்டிஃபிஷியல் வேரியபிள்ஸ் இன்ட்ரடியூஸ் பண்ணுறோம். அதை இன்ட்ரடியூஸ் பண்ணி அதுக்கு ஒரு ஃபீஸபிள் சொல்யூஷன் கண்டுபிடிக்கிறப்ப அது பாசிட்டிவாக வந்துடுது. அதனால நம்ம வந்து இட்ரேஷனுக்குள்ள போறோம். பட் நம்ம எப்போ சர்ப்ளஸ் வேரியபிள் ஆர்டிஃபிஷியல் வேரியபிள் ஆட் பண்ணாலும் அதை வந்து நம்ம அப்ஜெக்டிவ் ஃபங்க்ஷன்லையும் ஆட் பண்ணணும். அப்ஜெக்டிவ் ஃபங்க்ஷனில் சர்ப்ளஸ் வேரியபிளை நம்ம 0 கோஎஃபிஷியன்ஸோட ஆட் பண்ணுறோம். ஏன்னா இது நார்மலாக ஆட் பண்ணுதுன்னு சொல்லி. ஆனால் ஆர்டிஃபிஷியல் வேரியபிள்ஸை நம்ம ஆட் பண்ணுறப்ப நம்ம ஒரு பெரிய வேல்யூவோடு ஆட் பண்ணோம். அந்த பெரிய வேல்யூவை நம்ம கேபிட்டல் M அதாவது பிக் எம்னு சொல்லி டினோட் பண்ணுறோம். இப்போ நம்ம மினிமைசேஷன் ப்ராப்ளம் இதில் அப்ளை பண்ணுறப்ப அப்படியே அப்ளை பண்ண முடியாதுன்றதுனால அதை மேக்ஸிமைசேஷனாக கன்வெர்ட் பண்ணுறதுக்கு எல்லா கோஎஃபிஷியன்ஸையும் நம்ம நிகேட் பண்ணுறோம். நிகேட் பண்ணிட்டு தான் நம்ம இந்த இட்ரேஷனுக்குள்ளே வரோம். இந்த இட்ரேஷன்ஸ் எல்லாம் உங்களுக்கு புரிஞ்சிருக்கும்னு நினைக்கிறேன். நம்ம சிஜே மைனஸ் இசட்ஜேன்னு கால்குலேட் பண்ணுறப்ப இருக்கிறதுல எது சின்ன வேல்யூவோ அது உள்ளே என்ட்ரு ஆகணும். இசட்ஜே மைனஸ் சிஜேன்னு கால்குலேட் பண்ணுறப்ப எது ஹை வேல்யூவோ எது லார்ஜ் வேல்யூவோ அது என்ட்ரு ஆகணும். பட் இப்போ இந்த இட்ரேஷன் முடிகிறப்ப பார்த்தீங்கன்னா எல்லாமே வந்து உங்களுக்கு நெகட்டிவ் வேல்யூஸில் இருக்கிறதுனால இதோட நம்ம இட்ரேஷன் ஸ்டாப் பண்ணுறோம். அட் த சேம் டைம் நமக்கு எக்ஸ் வேல்யூவும் கிடச்சிடுது, ஒய் வேல்யூவும் கிடச்சிடுது. அதுலேருந்து நமக்கு -205 இசட்டோட வேல்யூவும் கிடைச்சிடுது. இது ஏன் மைனஸில் இருக்குன்னா இது ஒரு மினிமைசேஷன் ப்ராப்ளம். நம்ம வந்து அப்ஜெக்டிவ் ஃபங்க்ஷனை நிகேட் பண்ணியிருக்கிறதுனால. ஸோ இதுலேருந்து நம்ம இசட்டோட வேல்யூ வந்து 205 கன்க்ளூட் பண்ணுறோம். எக்ஸுக்கு 15 ஒய்க்கு 5/4 எந்த வேல்யூஸ் இங்கே வந்து எண்டப் ஆயிருக்குமோ இதுன்னு கன்க்ளூட் பண்ணுறோம். இந்த சொல்யூஷன் தான் உங்களுக்கு இந்த ப்ராப்ளமில் ஆப்ஷனில் கொடுத்துருக்காங்க. ஸோ 15 is the x value, 5/4 is the y value and we have got the solution as 205 in the simplex method also. Now we will move to the next question. The dual of the formulated LPP is. How do we find the dual is if the primal is given in form of maximization, the dual will be in the form of minimization. And if the primal is in the form of minimization, the dual will be in the form of maximization, just vice versa. So let's take the objective function z is equal to 12x plus 20y subject to the constraints 6x plus 8y greater than or equal to 100. Then we have 7x plus 12y greater than or equal to 120, where x comma y are greater than or equal to 0. We have to find the dual of the problem. In dual, whatever you have mentioned in inequalities, they will become the objective function variable coefficients. Here you can see C is brought to the constraint part and B is brought to the objective part. So this is actually a minimization problem. So this is the primal of this problem. The dual will have maximization. So maximize Z is equal to 100 plus 120. Now they have given u and v as the variables in the dual form in the options. So we will use the same variables 100u and 120v. Now subject to the constraints. For the primal we went column wise. For the dual you have to go row wise and then equate it to the objective function variable 6u plus 7v and then we will have 12 here. Then we have 8u plus 12v, then we have 20. What will be the inequality here? See, maximization, if it is in less than or equal to, in minimization it becomes greater than or equal to. They say this is A and this is A transpose. It means while taking minimization, if we go column wise, then the transpose will be, we have to go row wise. We took column wise for primal. It means for dual, we have to go row wise. This is the meaning of transpose here. We have understood that in the primal, if we have inequality as less than, in dual it is changing to greater than. So here it is greater than or equal to in the primal problem, which means here the inequality will be less than or equal to 12. And here the inequality will change to less than or equal to 20. Now just get the meaning alone. The cost should be less than or equal to 12, which says you are minimizing the cost, and the cost is less than or equal to 20, which says you are minimizing the cost. The meaning is not getting changed anywhere. Here minimizing the cost is an objective function. Here minimizing the cost is in the constraint part. Maximizing the daily requirement is in the constraint part and maximizing the daily requirement is in the objective part. What are x and y? X and y are greater than or equal to 0. Since both are positive numbers, here u and v will also be greater than or equal to 0. Now we will see which of the option is matching. So objective function is right in 1, 3 and 4. We will rule out option 2. Now we will check for the condition 6u plus 7v, 8u plus 12v. Here they have given 12 and 20. It is perfectly fine. And u comma v is greater than or equal to 0. Everything is fine for option 1. We will check the other options. Maybe a printing mistake. But here they have given u and v are unrestricted. We need not go for this. And here you can see the inequality to be greater than or equal to, so this is also wrong. And here you can also see it is 7V. Actually, it should be 12V and here it is 7V. More than unrestricted, these two equations are actually wrong. So we can mark option 1 to be the right answer. This is the perfect dual of the primal LPP. Next question. The minimum cost of food is as per graphical method, as per simplex method, we have x is equal to 15, y is equal to 5 by 4 and z is equal to 205. So option number 1 will be the right answer. Just substitute the values 15 and 5 by 4 in. Z is equal to 12x plus 20y. 12 into 15 plus 5 by 4 into 20. This will give 180 plus 25, which is equal to 205, the value of z. So this is the minimum cost of food, 205. With this, we are completing Unit 1 questions.